Okay, this is lesson 38, and the topic is called adding and subtracting whole numbers and decimals. Before, in the last lesson, we talked about adding and subtracting decimals. We might have had something like 4.2 plus a 7.3, and what we said, if you're going to paper and pencil that out, you line up the decimals. So you take 4.2 plus and then line up the decimal points like that, and you would add them. You would add the columns, so 3 and 2 is 5, and 7 and 4 is 11, and we'd have 11.5. Now the difference with this lesson is that we're going to have what we call whole numbers involved. So a whole number, remember, is just simply a number that doesn't have a fraction or a decimal. 4 is a whole number, 7 is a whole number, and so on. So let's take a look at example 1. And notice that I have a decimal plus a whole number. Well, what we do here, we have the 5.2. Now, you could think of 3 as 3.0. And you line up the decimals. And just like before, you add them up. And we get 8.2 or 8 2/10. So with a whole number, what we're trying to emphasize here is, for example, if I have 4, you could think of 4 as 4.0. The whole number 5, you could think of 5 as 5.0. And you can actually make it a decimal or have a decimal point. Really, in a whole number, as an 8, in a whole number, the decimal point is always located to the right of the whole number, and then add a 0. Let's take a look at example 2. Now here I have actually 2 decimals, which is more or less a review of the last section. So I have 7.4, I line up the 0.2, I line up the decimal points, like that, and I get 7.6. Now you could also line them up like this, 0.2 plus 7.4. And you get the same answer, right? Because the order you add numbers doesn't make a difference. Let's take 4.2, and I'm going to change this one actually. I'm going to take 4.2 minus 3. Right now, 4.2 is like that. Now, what's the decimal for 3? Remember, the decimal point's always located to the right in a whole number and add a 0. So I'm going to take 4.2 minus 3.0. Line up your decimals like that, and we get 1.2. So as you can see, we just add the decimal point and then we add or subtract them. Let's take a look at example 4 now. Now we're getting a different type of topic here with example 4. Here we're working with exponents. Now what's it mean if you have an exponent of 2? What's this mean if I have 3 squared? 3 squared means you're going to take the big number times itself twice as the exponent. So you have 2 of the 3's. 3 times 3 is 9. So 3 squared is 9. What's 4 squared mean? It means 4 times 4, or in other words, 16. What this doesn't mean, and the common mistake here, is if I had 3 squared, it does not mean multiplying the exponent times the big number. It doesn't mean that. It's not 6. It means the big number, the base, times itself. Let's take a look at 5 squared, which means 5 times 5, which is 25. 6 squared would mean 6 times 6, which is 36. Now, when I do these here, notice that I'm going to add something above here. I'm going to add a 2 squared, which means 2 times 2, right, which is 4. I'm going to add a 1 squared, which means 1 times 1, which is 1. Now all these answers, I'm going to put a square around them, all these answers, and if I were to continue doing this, all these answers right here are what we call perfect squares. And I'm going to extend on that with this next example. Now in example 5, and actually I'm going to extend on it here after this one, let's simplify this. How would I simplify 3 squared plus 4 squared? Well, before I add, remember our order of operations saying, please excuse my dear Aunt Sally? Notice that exponents come before addition. So I got to do my exponents first. Well, 3 squared, let's see, 3 times 3 is 9, plus 4 squared, 4 times 4 is 16. Now I add, and you get 25. So make sure you do the exponents before you add or subtract. Okay, now what I was going to extend on. Notice that I have these examples down. Now notice these are not division symbols. A division symbol does not have the hook. So in the black I wrote a division symbol. These that have a hook, these are what we call square root symbols. And when there's not a number in this hook, that means we're taking the square root. So what's square root mean? Well, square root means this. What number could I multiply times itself and get 4? Or in this one, what number could I multiply times itself and get 9? Or this one, what number could I multiply times itself and get 16? What number could I multiply times itself and get 25? Now if I go back a couple slides, remember I said I was going to refer back to this? Let's see, 1 times 1 is 1, 2 times 2 is 4, 3 times 3 is 9, 4 times 4 is 16, 5 times 5 is 25, and so on. These, I said, were perfect squares. Because, well, how about the first one? What number times itself is 4? 2. What number times itself is 9? 3. What number times itself is 16? 4. And what number times itself is 25? 5. So these are all called perfect square roots because there is a number that you can multiply times itself to get them. Now if I continue doing that, what's the square root of 36? What number times itself is 36? Well, 6. And notice that there's a pattern. 2, 3, 4, 5, 6. Let's see, 7 would be next. So what is 7 squared? Well, 49. Now I can also go backwards and say, hey, the square root of 49 is 7. What's the square root of 64? 8, right? 8 times 8. What's the square root of, what would be my next perfect square root? What would be the number that goes in here? Well, the answer to that would be, the square root of that number would be 9. Well, what's 9 times 9? So this number would be 81. What would be the next perfect square root? Take 10 and square it. What's 10 times 10? The next perfect square root is 100. So all these are perfect square roots. Let's simplify this. Now remember, before you add, you got to do the exponents or the square roots. So what's the square root of 4? What number times itself is 4? 2. Plus, what number times itself is 9? 3. And now we add, and we get 5. So the topic here was adding decimals and whole numbers and subtracting decimals and whole numbers, and also squares and square roots.